you should have opened up the second startup file so we can get to work on that. Today we're going to do some experimentation with data types and numbers and strings to see what we can come up with and see how they really work. So 45 your screen's eyes up here. Fantastic. So we talked yesterday about a string in memory. We also talked about an int, and we talked about a double and how they fit. Let's look at some code. When we go get a number using the scanner class, scan.nextInt, what's really happening is it's storing that number inside the box. Just like we talked about the postage box, it actually gets the letter when we're talking about a primitive. If we're talking about an object like a string, it gets a note inside the box that tells you where to go get your giant teddy bear. So if we look at this code here, scan next int, print line x plus this literal string. What does the plus mean in this context? 52 fist. What does the plus do? All hands have to go up. 52 fist. Victoria? Oh, sorry, you only had 2 fingers up. Shaylin? Yes, it's just going to put the number next to the string. Interesting, though, Java's concatenating that. That's the word we use. It's concatenating it. It's taking a number and putting it with a string. See, Java's a little bit smarter than we're giving it credit for. It knows that when you do a plus sign with a string, anything else that's with that plus sign is to be treated as a string. Now, if I did x plus 3, it would print out 10. It would actually do the addition first in order to get the math accomplished and then print it out as a string. Make sense? So suppose we run this program, okay? And the user decides to enter in the word cat. What is the computer going to do? 52 fist. So what happens here when you type in cat and press enter is Java just kind of like throws up on you. It's horrible, the errors that get produced. Like, it looks like you just did something really, really horrible. So they want to be really thorough in their error reporting. Everything that goes wrong, they just report. But really, the part that's important is this first line right here. It says input mismatch exception. It was expecting an integer and got a string. So the types didn't match up. Guys probably don't need to be typing anything right this second while I'm teaching. You can 45 your screen. 45 your screen. Look at me. I know. Wait until I tell you what to do. I got everything up on the board. So if I type in 4.5, what do you think is going to happen? So we type in 4.5, press enter, and again we get an error. Same error, input mismatch exception. And then a whole bunch of other stuff we don't need to worry about. So take a look at this set of code. And I want you to look to see if there's going to be any issues with it. Okay? So let's start with that. So it looks like all the code's fine. When we go run this and type in a 5, it says 5 is the number you entered. If you type in a decimal, we get 5.4. 5.4 is the number you entered. All seems happy. What would happen if I typed in a 5 for the second one? So think about that for a second. When we run this, it's fine, but it does something odd. We typed in a 5, and what it printed was a 5.0. What Java did was it said, okay, I'm going to take the 5 and put it into the double because it fits, but it still needs to be a decimal. So Java puts the 0.0 after it to identify it as a decimal. It has to have that decimal point to be a double. Java puts it in automatically. So in terms of string output, be aware that if you're storing an int inside of a double, it's going to have the 0.0. That's important to know if you're printing answers out. Sometimes for formatting, that's important to know. If you're trying to print out a time, and you're storing that time inside of a double, and then all of a sudden you're starting getting these weird decimal point numbers, it doesn't make any sense if you're talking about time. You'd want the integer. So a small value inside of a large value is fine. Java's okay with that. If you put something smaller inside of a larger container, Java will handle it just fine. If you try to put something larger inside of a smaller container, it's not that it's not okay. It's just you have to do something special to tell Java that that's what you really want to do. And then Java has to handle that. Because if you try to put something small and something bigger, it's fine. If you try to put something big and something smaller, something has to get amputated. It won't fit naturally. Something has to be changed. So you have to tell Java that's what you intend to do, and then there's certain consequences for that action. We'll talk about that. So what type of data type do you think you should use for each of these? We have age, we have an average rainfall, and we have a street address. I would like you all to take a minute and think about this, and then we'll go back and see which data type we should choose. So it looks like int would be the best choice here for age. Even though we could do a double, we could do a string. How about average rainfall? What do you think for that? Yeah, we want to use double because we want the decimal. That makes the most amount of sense. We could use a string. An int, that could be problematic. Go ahead. What were you going to say? Finally, street address. What should that be? A string. Because we can't make it a double or an int because there's a word associated with it. Making it a double or an int is not going to make sense. That really has to be a string. We don't have a choice for that. So here's an effect of what this actually looks like.
So here we have a double value
So
A,
here we have
and we're storing the
a double
number
value
3.5 in A.
and we're storing the number
Next, we have
3.5 in
int
A.
x equals 9,
Next, we
and
have
we store the 9
int
in the
x
box.
equals 9, and we store the 9 in the box.
Notice here the string is a little bit different.
Notice here the
When
string
we do
is a little
string
bit
W
different.
equals hello,
When we do string
hello
W
isn't going to fit
equals
in this
hello,
little tiny box.
hello isn't going to fit
So
in this
Java
little tiny
creates
box.
a memory reference.
So Java
It points
creates
to a
a memory
location that has
reference.
plenty of space
It points to a
and
location
stores
that
the
has
word
plenty of
hello
space
inside.
and stores the word hello inside.
So in memory, what really is happening, this box A has a number associated with it. It's at a particular memory location. And we store the 3.5 inside the box, but notice it's a bigger box than X. X is a smaller box because it's an int. And this has a memory address. But here we have what's called a pointer, and it's pointing somewhere in memory called the heap. You know, it's just a heap of stuff. Right? Makes sense. And that's where hello is. But suppose I identified something else. Put another tag on the box where both tags are on the box. That's okay. You can have more than one tag on a box, more than one reference to a particular memory location in the heap. And then if I were to cut this ribbon, this would no longer know what was inside the box. It would lose all connection. but the information is still actually in the box. The information didn't go anywhere, and there's still this tag here on the box. If I were to cut this tag too, the information is still in the box. We did not delete the information. That's very important to understand. You're not deleting the information when you remove the reference to an object. You're just forgetting where it is. Now, Java has this little thing built in called garbage collection, and that's truly what it is. It goes around and collects any objects that are not associated with a reference. And it does that periodically. So we'll go through and say, is there anything that's not associated? Great. Let's throw out the trash. Let's get rid of anything that's not associated. If it's associated, it leaves it alone. Now, if I go up here and delete the value that's in this box, then it's deleted. Now, in Java, we don't actually delete it. We'd have to put something in the box and replace it. Even if it's something called null. That's a thing. Nothing. We're telling Java, don't put anything in the box. So it replaces or overwrites what's inside the box. We don't actually delete anything in computer science. The word delete is a misnomer. There's no delete. You either forget where it is, or you write on top of it. And even if you write on top of it, sometimes you can get to the information that was there before. Just like a painter paints on top of another canvas, you can remove the top layer of paint and the original information could still be there. Could still be there. Unless you really do something like a bit clean and wipe it out, or bit bleach, right? That's the thing that was in the news, right? Bit bleach, wiping out the email. So there's a couple things that you guys are going to be responsible for in this lesson to actually work on. The first is going to be the exit ticket. After the exit ticket is completed, you can work on the data type exercise, which is a worksheet that asks you to go through and kind of sort and play with data types to see which is which. And we'll go over those two things. Do not move on to the practice until you've gotten feedback on the data type exercise. Do not move on to the data type exercise until you've gotten some feedback on the exit ticket. Don't take the exit ticket 15 times just trying to get the answer right. Wait for some feedback, because I saw some people just making the same mistakes over and over again, and sometimes it wasn't a mistake. It was just like you had a space different than the computer was recognizing as the right answer. So just take the exit ticket one time, wait for feedback, and then move on to the data type exercise. You can at least download the worksheet, though, once it opens. All right, so that's it. Why don't you guys do the exit ticket now?